This ad-free episode of Out of Patience is brought to you by Elevation Oncology, elevating precision medicine to the forefront of every cancer treatment journey. We believe that every patient deserves to know what is driving the growth of their cancer and how best to treat it. For more information, visit nrg1fusion.com/pod. That's the letters NRG and the number 1, fusion.com/pod.
I mean, no one plans to get sick, and yet, here we are. My name is Matthew Zachary. I survived cancer, a stroke, and COVID-19, and somehow I'm still here. I also survived our stupid, broken healthcare system, and I want to help you survive it too. So let's go make healthcare suck less together. Because you know what? We're all out of patience. Hey, that's the name of the show. Hello, friends. Welcome back to Out of Patience. Before we get started, I want to invite you, if you haven't already, to follow our groundbreaking documentary series, The Cancer Mavericks. These are stories about the people rather than the disease. It's the 50th anniversary of the signing of the War on Cancer, the National Cancer Act of 1971, and we're profiling the insanely extraordinary unsung heroes who challenged the system. They forced the government to listen. They forced doctors to just do the right thing. This is a compelling series. You got to listen to it. Thank you so much. Go to cancermavericks.com or just search for Cancer Mavericks wherever you listen to your podcasts. On the show today, I welcome the esteemed Dr. Stephen Liu. Prepare for lots of credentials. He is the Associate Professor of Medicine, Director of Thoracic Oncology, and the Director of Developmental Therapeutics at Lombardi Comprehensive Cancer Center of Georgetown. Whew. At a time when cancer treatment is more about your DNA and your RNA than where it is in your body, it's more important than ever to continue elevating the conversation about making biomarker testing a mandatory part of care. What is that? You're going to find out on the show. Why napalm everything in your body if your genes make you eligible for a specific kind of therapy that's way better than napalm? NRG1 fusion is found by an RNA test done on solid tumors. For the purposes of this episode, I'm talking with Dr. Liu, who's an expert in lung cancer tumors. But this test, the NRG1 fusion test, is something everyone with cancer needs to get out of the gate. You enter the I have cancer store and boom, you should get this test, which can make or break the trajectory of your care, because in addition to this NRG1 fusion, there are other fusions, other mutations in your body. Wouldn't you want to know that there's a treatment option for you? Again, no napalm, please, no napalm. So from the seriousness of phase 2 trial enrollment challenges to the inane musings about Dartmouth, Boston Market, and the children's book, The Three Billy Goats Gruff, I kid you not, strap in for a serious conversation about precision oncology and biomarker testing, especially if you or someone you know has lung cancer or any other solid tumor that could benefit from NRG1 fusion. Enjoy the show. Dr. Stephen Liu, welcome to Out of Patience.
Thanks for having me. Pleasure to be here.
That voice, I got to tell you, you got good equipment on your side.
Well, they do say I have a face for radio. I don't know about the voice.
Well, you do have a voice. I kind of saw your face on the internet. You know, not bad, but your voice is great. Fantastic. Whoever set up your tech, good job.
Thanks. Nice of you to say.
So you have a million credentials. You're very Googleable, like all this great stuff. But I couldn't help but notice there was one thing in your CV that I don't usually see conflated with or comported with or in adjacent to your field, which is that you have a minor in film and media studies. I have to know more about that.
I'm actually only about 3 credits shy of a double major. I went to Johns Hopkins for undergraduate, and just by chance, I was roomed in my suite with a lot of athletes. And My focus was primarily on science, on biology, and a lot of labor-intensive courses. And I really just needed something a little lighter to sort of help float my GPA a bit, if I'm being honest. My colleagues that were on the football team all sort of were taking these film and media classes. So the first film class I took was a seminar on Pedro Almodovar, pretty intense films. I remember we set up in the back with a bunch of Boston market dinners, watching movies in the back, sort of taking notes, and it was a lot of fun. It was actually really hard. And at the end of the day, it actually brought my GPA down a little bit, but I was fascinated by it, by how you could tell a story through film. Made me, look at movies in a different way. And I really loved it. I've loved it ever since. So I stuck with it. The only one in my group of friends that actually saw the class through. Everyone else dropped it because it was quite hard. But as I said, it brought the GPA down a bit, but really it's been a passion. And I think that when we think of what we do in medicine, it's communication, it's teaching. And I think that you learn so much of that just from film. I think that we're all just communicating with each other about different topics. And I do think that there's a lot of carryover from one to the other.
Well, first off, shout out to Boston Market, not a sponsor, but my God, you just brought back all these memories for me from college. So good job on that. And jumping into the deep end of the pool with that course load, that's incredible. I can't help but comment on how I did the same thing. I wanted my easy A. And at Binghamton, where I went to college for undergraduate, they had Theater 101, which everyone was like, easy A. And yet the professor knew everyone thought it was an easy A, the most incomprehensibly difficult course of 8 years of college. And it brought my GPA down for freshman year. So I feel you on the whole thing. But at the end of the day, here you are working in medicine. You've been doing this for quite a while. We have TGen in common. I'd like to talk about your work at TGen.
Yeah, so TGen, Translational Genomics, I went there after my fellowship before I took my first academic position. And when I finished my training, which was 2011, we were just entering this field of genomics, learning a lot more about cancer. And it's an area where we didn't get a lot of training in it. And so I took it upon myself to really seek out who the experts were and see if I could do not really an apprenticeship, but just get a little more experience, a little behind the scenes, sort of peek behind the curtain. So I sought out one of the legends in oncology, a guy named Daniel von Hoff. And Dan is a guy that was responsible for most of the chemotherapy drugs we were using at the time, was on the forefront with personalized medicine, genomics. And I took a shot and emailed and said, hey, would it be okay if I just kind of learned from you for a little bit? And, to my surprise, immediately responded, actually put us up, sort of gave me an apartment down there and spent some time working at TGen, learning what they were doing, learning sort of what is sequencing, sort of how do we get these answers to the questions we're asking. And also, very good fortune, spent a little bit of time with him in his clinic, which I will say is probably the most influential time of all my training in terms of the oncologist I am today.
Well, I mean, God, right place, right time. That's incredible. I want to go back to what you said before, which is at the time there was a lack of training in genomics. Has that been fixed?
A little bit. Things are slow to change. And in the past, oncology was really managing the side effects of these very toxic and dangerous medicines, these poisons, sort of controlling them in a way that was safe. And it shifted 180 degrees to really much more precise medicine. This is a field that is completely changing. When we look at molecular genomics, a lot of the training we're doing now are things that oncologists 10, 20 years ago had no exposure to at all. And it's really tough to change a field. But I think that's probably true with all of medicine, that as the times change and we have new paradigms, we have to relearn a lot of the field and redefine that field. So that training wasn't around. I knew it was going to be important. So I sought out who I thought were the best there. They took me in. And, my time at TGen was so important to the doctor I am today that even now my patient approach and things that I do when I see a new patient for the first time, I steal that. I stole that completely from Dan von Hoff. I just liked the way he did things, and that's really how I run my career.
It's kind of like where behavioral practice and awareness of the dogmatic principles of progress in medicine conflate with who you know. And have you created disciples? I feel like there's a positive use of the word metastases here where you can now endow this to other people.
I've not heard it used in that way. I think that's pretty clever. I am always struck by how arbitrary our paths are. And when you think of all the little things that happen to get you where you are, there are people who are experts in lung cancer who didn't start in lung cancer, or maybe who wound up in lung cancer just by chance, by circumstance. And there's so much of that. So it is a lot of connection, who you know, maybe just who you have the good fortune to be trained under. And I think that there are people I work with that have adopted things that I do. But when I'm talking to fellows, to trainees, I really try to encourage them to sort of look around and steal, borrow from other people that sort of shapes who we are. And a lot of it is circumstance, a lot of it is chance, and just who you happen to work with. Medicine, despite all of the advances we've made, despite all the new technology we have, is largely an apprenticeship.
So as of this recording, as of this production, we're in the midst of releasing an 8-part narrative series on the 50-year history of cancer survivorship, cancer advocacy. And in episode 1, we profiled Sydney Farber and the origins of chemotherapy, right? And this whole idea of napalming people, I was diagnosed 25 years ago, I was napalmed, to this idea that, your DNA matters now more than just napalming you. What has been your observation over the past couple of years, seeing this evolution in medicine from, I'll just say, napalm to things that actually work just for you?
Yeah, it's a field of rationally designed medicines where it's much more logic. And while we're very good at giving chemotherapy or napalm, as you put it, and we're able to sort of anticipate and minimize a lot of the side effects, when we think of just the bare bones of chemotherapy and whether these drugs will work, it's largely a guess. We're giving similar cytotoxic chemotherapy drugs, based on things like nitrogen mustards and sort of very dangerous compounds. We give the same medicine to everybody, and we hope that it works. But we also realize that it's not going to work for everyone the same way, because every cancer is a little different. Every person is a little different. So to have a one-size-fits-all treatment, we sort of play the odds. When we look at the big trials through oncology, we have drug A, we have drug B. Drug A works 20% of the time, drug B works 15% of the time. So drug A is our preferred drug, but it's still a guess. And back then I wouldn't be able to tell you if you were in that 20% or if you were in the 80%. It was a little guesswork. And where we've come now is taking a little of the guesswork out of it, sort of being able to predict with a little more power, sometimes a lot of power, whether a drug is truly going to work or not. And we have a long way to go. But when I look at where we were, it's just much more elegant. It's much more sophisticated.
I mean, I sit on the side of the consumer. Regrettably, there are no real agency creatives in academia. So these syllables come out. They keep coming out. It used to be experimental medicine. I'm thrilled we finally got rid of that. But now clinical trials have been changed to precision medicine or personalized therapies or immunology. Where are you in terms of helping the average, I'll say the poor schmuck as a metaphor, no one asked to be in the cancer store, but you're there. How are you supposed to know what these fancy things mean?
It's tough to get past a lot of the jargon, and we try to make it as accessible as possible. But I think that ultimately, when we think about precision medicine, personalized medicine, we're talking about the same thing, and it's really trying to deliver with more detail what is your cancer, what's important to your cancer, because if something is really important to the cancer, while the cancer may view that as a strength, we would view it as a vulnerability. Where if the cancer is relying on some unique aspect of the cell, what if we take that away? And it comes down to really classification. I think that we all agree that lung cancer is different from leukemia. Those are completely different cancers, and they're treated in completely different ways, which makes a lot of sense. But we now realize that within lung cancer, there are dozens of different cancers that all happen to occur in the lung, but their presence in the lung is not what defines them as a cancer. It's not what drives them. And so it's hard to leverage that against the cancer. At the DNA level, if we can look at the protein level, look at something more specific to the cancer, then we can identify a treatment that's going to be much more likely to work. So we're looking for vulnerabilities. We're looking for something unique to this cancer in front of me, and a treatment that makes much more sense. So we're not guessing, we're not hoping, we're now kind of expecting.
I had a colleague explain this to me in a great way. They said, this is the end of cancer geography.
Yeah.
and the start of like Mr. DNA from Jurassic Park. I mean, I'm Gen X, so I don't know who's going to remember that reference, but the layperson's guide to how treating your cancer is different than treating you with cancer.
That's right. That's exactly right. And sometimes the fact that this cancer is in the lung is the least important part of it.
Wow. Mind blown. I love that you just said it that way. So let's get into some of the nitty gritty details, which is like, all right, let's go back to the patient. They get lung cancer. We won't get into why right now, but just be your own advocate. Like, not everyone is born with chutzpah, moxie. Not everyone has that innately in them, and they're terrified and scared of these windows. Who's responsible to really create that, we used to say shared decision-making, like it's a nice little batch of syllables, but what does it really mean when you're there talking to that human being?
I think what it means, and to answer your question sort of flat out, I think the onus really is on the oncologist. The oncologist should be the one sort of bringing this up. But when I think of shared decision making, it's a realization that my values as a person are not necessarily the same as the person in front of me. That we need to make a decision in front of me, and maybe I don't know what's best for this person at this point in their life. And I need to help them make the right decision for them. So I don't want to assume that their values are the same as mine. It's laying out the different options. It's still making a recommendation. I don't think that I'm just presenting a menu of here's the different things you can do. I think it's my responsibility to say, here's what I recommend and here's why. And, these are the pros and these are the cons, and letting the patient ask questions, digest the information, and really see if they come to the same conclusion. Say, well, you know what? That's not as important to me as this, as sort of feeling this way, as avoiding these side effects, as doing this at this time of my life, and having these different values. I think it's important to acknowledge that. That's really the heart of shared decision making.
Back with our guest after the break.
This ad-free episode of Out of Patience is brought to you by Elevation Oncology. If you or someone you know has a solid tumor that is tested positive for NRG1 gene fusion, then please listen closely to the following. The Elevation Oncology Crestone study is open and enrolling for patients whose solid tumor has tested positive for an NRG1 gene fusion. If you are not sure whether or not your tumor is positive for an NRG1 gene fusion, then talk to your doctor about getting tested with RNA-based testing. For information on the Crestone clinical trial for patients with solid tumors identified with an NRG1 fusion, contact Medical Affairs at elevationoncology.com and visit nrg1fusion.com/pod. That's the letters NRG, the number 1, fusion.com/pod.
So you just ended that segment with something really fascinating. Again, I mentioned I was diagnosed 25 years ago with what they thought was terminal brain cancer. If someone was able to ask me back then, what's important to you, instead of here's what we're going to do to you, that would have changed everything. Are we really at that point now where there's a wokeness in doctor-patient relationships that is something that just kind of comes out first?
We have to be. And the paternalistic standpoint of, I know what's best, here's what you should do, I'm the expert, that is really completely out of fashion, that's misguided. It's really, here's my experience with these medicines, here's what will happen if we go down this route. And there are good parts of that, but everything comes with a cost. And, a lot of times it's not necessarily a financial cost, although that is a big part of it, but there are toxicities now, there are risks of toxicities later. And again, you just don't want to assume. You know what they say about assuming. So I need to
Yeah.
I need to put it out there and say, but I make a recommendation. Here's my recommendation, and here's why. Here's why I think this is the best treatment for you. But again, they have an equal voice. Actually, I would say that they have a bigger voice, because ultimately it's going to be their decision. I need to help them make the best decision for them at that point in time.
So how do you and the other yous, especially in the lung cancer space, keep up with what's available to patients in terms of trying to avoid the default standard of care as the only thing you can talk about?
It's moving so quickly. We have approvals all the time, and you need to stay current. It is hard. I have the good fortune of only treating lung cancer. And so every day when I wake up, I read about lung cancer. I stay up to date on lung cancer. I only talk about lung cancer. If I were charged with treating 10 different cancers, each so complex, I think it's hard to really get any depth there. And so if I need to know what the standard is today for breast cancer and brain cancer and lung cancer, I don't think that's possible in 2021. And so for me, it's depth and that expertise. And if you're treating all different types of cancers, it's very hard to be completely up to date on all of them.
Are you finding that more and more patients are open to these conversations, that it's not scary that you talk about, biomarkers, your DNA? I mean, again, too many syllables often sometimes on those conversations, but clinical trials, again, they've evolved. I think there's less boogeyman for them in general, maybe not in niche communities. But this idea of going on a phase 2 trial, a phase 3 trial, is the word trial itself something you have to kind of get past that language barrier to your patients?
I think that patients are more receptive now if I explain it right. I really think that the onus is on me to make sure I'm explaining it properly. It's not going to be right for everyone. Not everyone's going to be comfortable with it. But today, in many cases, the best possible treatment will be on a clinical trial. Our regulatory process, the path a drug goes from being discovered, being developed, understanding it works to full approval and coverage and availability to everyone takes many years. And there's going to be a window where I know that a drug works well, that I know this is the best drug that's available. It just happens to not be approved yet. And the only way to get access to it is through a clinical trial. In those circumstances, trials are really the way to get drugs years before they're available to the market. We see commercials now and a lot of stories about immunotherapy drugs that have been approved in the past few years. And what I try to explain to my patients is those are drugs that are not new to us. We've been doing those trials now since 2012, 2013. Those are very old drugs. To us now, we have a whole new wave of drugs that have come along. And in many cases, trials really are our best possible option.
In terms of just modern relevancy, it's 2021. This country is slowly coming out of the pandemic. In some of my talks, I actually referenced the way that culture has been receptive or averse to the idea of vaccines. Like, they rushed it. No, mRNA has been around for a long time. They just kind of applied it for the first time. Very different, right? Or we just talked about how some people are hesitant to get it until the FDA fully approves it. But EUA, which is Emergency Use Authorization, is kind of akin-ish to phase 2, phase 3 trials. I feel like there's an odd connection between how do you explain this and that.
Yeah, I would agree with pretty much everything that you've said. First, the mRNA piece, I had a chance to speak with the CMO of Moderna, and when we talk about vaccine development, how do we develop this so fast? His answer was, this wasn't fast at all. We've been working on this platform, this technology to develop cancer vaccines for years. And all we did was replace cancer, which is different in everybody, with a virus that was pretty much the same in everybody. So that was really a walk in the park compared to cancer. The time, if you count the time from developing the entire platform, it took many, many years. It was just sort of adapting based on the current need. But FDA approval in and of itself isn't necessarily the best mark for how good a drug is. When we look at some of the tests we do for cancer, there are FDA-approved tests for biomarkers in lung cancer, and I can tell you now those are not very good tests. They are the FDA-approved test, but that's not the best test that's out there. And a lot of the treatments we're using for cancer are not being used based on an FDA approval, based on other evidence and other recommendations. But FDA approval isn't the end-all, be-all when it comes to cancer care.
I feel like we have to unwire our cultural bias towards the good housekeeping seal of approval being FDA approval.
They're just words, absolutely.
So let's get into these ideas of biomarker tests. So X person has lung cancer. You're at a comprehensive cancer center. Is it too easy to say that it's potentially in everyone's interest to be at a comprehensive cancer center that has this infrastructure of awareness versus a community cancer center? Or are you finding people in local areas coming to Lombardi or to other comprehensive cancer centers?
I think that there is value at an NCI designated comprehensive cancer center in terms of experience, in terms of access to the multiple disciplines, but I don't think that all care needs to be delivered there. A lot of patients I will see for an opinion, maybe I'll see periodically to help make sure they're on the right track, to provide that reassurance, to make some suggestions. But most cancer care in the US is delivered in the community, just in terms of volume. And I think the care in the community, for the most part, is excellent. But sometimes we can offer certain expertise with unusual circumstances that I do think provides value.
So you just started a phase 2 registrational trial. Help me understand what registrational trial is. I mean, again, acronyms and syllables.
Registrational means that if this study pans out as expected, as we anticipate it to, that it has the potential to lead to an FDA approval. These are sort of designations that are worked on by the sponsor of the study and the FDA before the trial starts, looking if we power the study in this way, if we have this many patients, if we show this degree of benefit, could this potentially lead to an approval by the FDA? And so registrational means it has that potential for approval if it shows the activity that we expect it to.
So there's a bit of a gatekeeper model here, right? You get lung cancer, you're diagnosed, you have to go through this test to see if you have the DNA that works for this particular trial, right?
That's correct. Now, that testing, that biomarker testing, that DNA testing, genetic testing, all talking about the same thing, that is critical for everyone with lung cancer. And it's not just at a designated cancer center. This really would be the standard of care across the world. And what we're seeing is, unfortunately, not everyone is getting that standard, but they absolutely should be getting that standard.
I'm going to go way back. The three Billy Goats grow up. They're trying to cross the bridge. There's like a troll under the bridge, and he puts them through tests, right? How do you get the troll to let the goats over the bridge every time? And you just said, like, getting biomarker testing to be standard. Like, it's just what you get once you're there. By default, you get it. What are the barriers to making that a thing?
Well, there are a lot of different barriers. When we talk about biomarker testing, what we're doing is we're testing a patient's tumor. We are subjecting that to analyses to look for these genetic changes, to look for these biomarkers. And to do that, we have to have tissue. There has to be a biopsy. Everyone with lung cancer has a biopsy. That's how we diagnose a lung cancer. But there needs to be enough tissue left over to do this testing. And that's sort of the first barrier, because that's kind of a big shift. If we go back 20 years, when we're making diagnosis of lung cancer, for example, any cancer, we're using the smallest needle we can because we want to minimize the risk. We don't want that needle, that biopsy, to do any damage. So we're using the tiniest needle, getting the smallest amount of tissue, the bare minimum we need to make a diagnosis of cancer. That is out the window. And now, if we do that small biopsy and they come to see me, I'm going to send them for another biopsy. And now the risk is even greater because we need more tissue. Because saying this is cancer is not enough. Saying this is lung cancer is not enough. I need to know the genetic makeup of that cancer if I have any chance of treating it properly.
So this goes back to, is this a right? I mean, we talk about, like, there's no 21st century Patients' Bill of Rights. Those are 20 years ago. And, like, it so needs to be updated to whatever version is of the deservedness of knowing a test is there for you. Is there a version at all in the oncology space to let patients know about these tests?
You know, there's not a Bill of Rights that sort of outlines that, but I love that you put it that way because it absolutely is a right. If I don't have that information, I cannot treat that cancer properly. This is not some optional test where I can say, well, things could be a little better. It might open things up a little more. Let's go for it. This is essential to proper care. It's not an optional test. So let me run through an example. If I look at a biomarker, most common biomarker I'll see in lung cancer that's actionable in the first line setting would be in a gene called EGFR. All right, so I'm talking about a part of the DNA in the cancer that is abnormal. Now, this is not DNA that we inherit from our parents or pass on to our children. It's DNA that's been altered in our adult life for unclear reasons. But this part of the DNA is damaged, is changed, and then that leads to a cancer. That's how the cancer is born. And if I can pick up that change, I can match that to a targeted treatment. That's the precision piece. It's looking at that specific change in the DNA and then matching it to a list of pills I have. You take this once a day pill. It's going to work for almost everyone. It's going to work almost immediately, relatively few side effects. It's going to work for a long time. It's the perfect treatment for this specific DNA change. And if you don't have that change, it has a 0% chance of working. But if you have the change, it's almost always going to work. And so we have that match there. But it goes beyond that, because if I don't know that that's there, if I don't test for it, if I don't find that DNA change, the standard of care in the US now, without one of those DNA changes, would be immunotherapy. But guess what? Immunotherapy doesn't really work if that change is there. So not only am I missing out on a very effective, well-tolerated pill that's going to work very well, not only am I missing that by not doing the tests, but I'm giving a treatment that has almost no chance of working, will have more side effects, will be more expensive. And if I get them in the wrong order, if I give that immunotherapy first and then realize my mistake, go back and give that targeted agent, all of a sudden it's much more dangerous. We don't really know why. So the stakes are really high to get it right and to get it right the first time.
I love that you stated it just that way. One of the things I've been fascinated by as an observer on the patient side, how these new innovative drugs and therapies aren't just for one cancer geography. They treat multiple different things if you have the right DNA. And I do want to talk about, again, in the interest of like acronyms, NRG1 fusions. So just for the listeners, that's the letter N, the letter R, the letter G, one, I guess like energy, but who needs vowels? E, and maybe sometimes Y, E. So it's NRG fusions. What is this?
NRG1 stands for neuregulin 1, and this is a gene that we've done a lot of work with at Georgetown, one that I find very interesting. When you have this specific DNA change, this chromosomal rearrangement, this gene fusion, it turns a normal cell into a cancer, and it's very rare. It's about 0.2% of cancer. But what's interesting is it's not something that's unique to lung cancer, to breast cancer. We can see these in all types of cancers. And it is something that we have many exciting treatments that could be effective. They're not approved treatments. These would be available through trials. But what we're seeing early on is very exciting. And I know that there are people out there that are getting chemotherapy, that are getting immunotherapy, that are getting treatment for their cancer that have one of these fusions that just hasn't been detected. And to me, it's a tragedy. It's a travesty that we're not finding these when they're present. But I know they're out there. It's an area where we've done a lot of research.
So this is the thing, mentioned like the proverbial gatekeeper. You get the test, and this is something they could find in you. You have this fusion inside your body somewhere. In your DNA is this.
It is in the tumor DNA, and so within the cancer. But what makes this biomarker, what makes this change unique, is that it's really hard to find, and not just because it's uncommon. For sort of mechanical reasons, you need to do certain types of biomarker testing to really find it. And again, this makes the job harder for a lot of oncologists maybe trained a little while ago. When we talk about biomarker testing, there are FDA-approved tests. And it's very reasonable to use those. If I was taking some kind of board certifying exam, I would choose these FDA-approved tests. In practice, those tests will not find NRG1 fusions. They will not find a lot of the genetic tests that we need to find. So the currently approved tests are simply not very good. They're going to miss a lot of them. So when we talk about biomarker testing, we're talking about testing DNA, but for NRG1, it's actually a little more efficient to test RNA. And the reasons has to do with the size of the gene and a lot of the limitations with the technology. But when we order biomarker testing as an oncologist, now I need to know exactly what test to order. I need to know, is this test, this commercially approved, FDA approved test, is this testing DNA or is this testing RNA? And in that way, a medical oncologist in many ways needs to be a molecular pathologist, because I need to know that level of detail. NRG1 is one of the several important biomarkers that is going to be much more likely to be found if you're doing RNA-based testing.
Right. And just to round this out, like patient A gets lung cancer. They get into the cancer store. You're there to greet them. You're talking through all this information with them. What do they need to do to get this test? It's like, you can't have this because you went to Dartmouth, right? Like, what are the things that exclude you? Sorry, no offense to Dartmouth, but
Right.
Like, What are the things that make you ineligible for this stuff?
Everyone needs to have this type of testing. That's the thing, is really all patients should be getting it. Now, it's limited to non-small cell lung cancer, non-squamous for sure, but really anyone with lung cancer, I think, should have this testing. I think this type of testing is relevant for anyone with cancer. What's the barrier? If you have enough tissue to do the testing, if there's a biopsy that was done somewhere, that leftover biopsy specimen is retained, depending on state law, many cases for a decade. And so that's sitting there in a lab. We can send it off to a lab and get this sort of state-of-the-art RNA-based with DNA-based next-generation sequencing or full biomarker testing. What's the barrier? The barrier is cost. Now, for most patients, this will be covered by insurance. There may be some copays, but the biggest barrier remains cost. If we removed the cost aspect of it, this would benefit, I think, many, many more people. I also find that there are ways to work around that cost. And this is something that, oncologists need to ask their patients. Again, so making the assumption that I say, well, this is kind of an expensive test. This might be $500. This might be $100 out of pocket. I don't think it's worth it. Again, that's my value. And so I need to make that decision with the patient. Say, we have this test. Maybe there's a low chance we find something. There's a chance you may be responsible for this much money. I shouldn't make the assumption that it's not going to be worth it, because it very well may be worth it for a specific patient.
Yeah, I feel like the whatever it takes to cure me, metaphorically speaking, should not be ruined by I can't afford this.
But those assumptions are being made, because I think the only barrier to that realistically is cost. We can also sometimes do this type of testing from blood tests, from plasma tests, from a simple blood assay that takes about a week to get back. These are, I think, very heavily underused. In the era of the pandemic, a lot of these companies will also just send someone to your home to draw the blood, removing even more barriers. So that brings us to another big barrier to this biomarker testing, and it's just awareness. It's just education. Because a lot of oncologists that are very busy treating many different types of cancers maybe aren't aware of the impact that these rare alterations can have. And again, it's hard to stay up to date with things. Many of these are being explored through clinical trials where they don't have exposure to it. So having that awareness that the testing can make such a big difference, it's hard to reach people that have already finished their training, that are already done with their training, because they're busy working, they're busy seeing patients. They're not in the classrooms, they're not taking more classes.
So is the ultimate moral of the story, if you're diagnosed with lung cancer, or in particular any cancer, but in this case specifically lung cancer, are you supposed to ask your doctor for this test? Are you assuming they're supposed to tell you about this test? Or is it somewhere in the middle?
The oncologist should be providing that information, but patients need to advocate for themselves sometimes, unfortunately. And I welcome those discussions. I also think very good advice to anyone with cancer. Cancer is a serious disease. And if you're diagnosed with cancer, you got to get another opinion. Nowadays, we're able to do a lot of these remotely through video. And so you don't even have to leave your living room. But everyone with lung cancer, anyone with any cancer, I think, should have another opinion. There's only value in getting more perspective of things. No oncologist who's aware of it and who's confident what they're doing is going to take offense at that. Patients that I treat, that I diagnose, I encourage them to get a second opinion somewhere else as well. You need to hear it from more people. So getting another opinion to stay on top of things, just to have that peace of mind, I think is very important. When it comes to biomarker testing for lung cancer, for any cancer, I think that if a physician hasn't brought it up, the oncologist hasn't brought it up, then the patient or the patient's family absolutely should bring that up. And there's nothing wrong with conversations, with having these talks, and I do think that should be done more.
So the website that we're inviting all of our listeners to go to learn more about, is there a test? Ask for a test. It's so important. Like you said, not everyone's born with moxie, but at some point, I just only wish patients were given, like we said, the rights. What are the rights to have? But the website is NRG1 Fusion. Again, that's like the word energy without the vowels. NRG1Fusion.com/pod. NRG1Fusion.com/pod. Dr. Stephen Liu, thank you so much. I'm going to have you back. This is exciting. And your voice, that voice. Come on. Good job. Amazing.
Absolute pleasure. Thank you for having me.
That's all for today, folks. If you like today's show, be sure to subscribe, leave a review, follow us on social, and tell all your friends to listen. Out of Patience with Matthew Zachary is a product of OffScrip Media. Our executive producer is Matthew Zachary. Our senior producers are Brianna Seeley, Jen Oranger, and Andrew McDowell. It is mixed and edited by Brianna Seeley. Our theme music is by the Mike Van Allen Quintet and by Mara. For advertising and media inquiries, email media@offscrip.com. Hit us up at contact@offscrip.com to share comments, feedback, and make recommendations. For more information, visit offscrip.com.